Good morning, Dr. everyone. My name is Ji Hong, and today my group and I are going to present about our MKS Lab 1, which is entitled The Calibration of Level Transmitter for Level Measurement. So these are our group members, and I will be the team leader for this lab. Okay, so first of all, for this lab, we will construct the block diagram systems of the desired systems in the Simulink app in MATLAB. Then these are the components that we use to construct the systems based on the figure 1.4 figures in the lab sheet for lab 1. So first of all, the components for this system will be, we are using the repeating sequence there, which is representing the tank liquid level, where we can set the level of the tank, liquid level of the tank by setting the vector of upper values as what we want, and the sample time we can set it as what we desire also. Okay, then for this part, it will be the part for reference for level measurement. So we are using a transfer functions block as our as the part for this reference or level measurement. Then the signal from this part will be declared as the signal one. Okay, then for this part, it can be considered as a part B. So we will use this part as a level measurement. So for this part, we have a transfer function block, which we use it as a level sensor. It represents a level sensor. Then we have a product, which will multiply the values from level sensors with the constant block, which is representing a calibration gain or zero and span. Then this calibration gain actually, we can use to get our desired results. So we can change this constant value as what we desire to get the minimum error that we want for the result. So here, as from the figure 1.4, we are using 0.8 as the first value to our lab 1 part A. So then we are using initial condition, constant block as an initial condition 2. Then the signal will be going through an adder, and the output of the signal will be the signal declared as the signal 2. Then the signal 1 and signal 2 will be going through the bus creator and output to a scope and to a workspace in order to analyze the results for our lab. So as we can see, this will be the sample result for our part A. Then that's all from me. Then I will pass to my next members to continue with the other parts of this lab. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zambi bin Yusuf. My number is DE100096. Okay, now I would like to present for the part 1 for the result. And okay, for the part 1, we must to find the level reference data signal 1 and level measurement signal 2, and also error and error square. Okay, for the level reference data, okay, we use the MATLAB, and this is the MATLAB for the part 1, and this for the scope to find the signal A, signal 1 and also signal 2. Okay, this is for to find the signal for the signal 1, and we find, for example, time 199, and you can get the data for the level reference 24.9988. Okay, okay, for the time the 399 we also use for the same method, and how to find the level measurement for signal 2, and we use also for this from this, and okay, we sync out the signal 2 and we find the time. Okay, for example time 199, and for the data signal 2 we get the 20.5989. Okay, now we get the result for the part 1. Okay, for the time 199, we get the reference same from the this data, and okay, for the error we get 4.399, and for the error score we get 19.3591. Okay, for the time 399, we get the error 6.1600, and for the error square we get 37.9456. Okay, for the time 599, we get the error 5.2800, and for error square we get 27.8784. Okay, for the time 799, we get the error 7.0400, and for the error square we get 49.5616. Okay, for the time 999, okay, we get the error 4.400, and for the error square we get 19.3600. Okay, for the calculation gain we get 0.8, and for the mean square error we use this formula: a plus b plus c plus d and plus e divided by 5, and we get the answer for the mean square error 13.8209. Okay, that's all for me. Thank you.
Greetings to Dr. Muhammad Hafiz. I'm Ahmad Koyum bin Ahmad Jahan. So I'm going to continue with the second part of the experiment, which is part B. Okay, so based on the instruction K as shown in this screen, okay, we are required to change the calibration gain to somewhere in between range from 0.8 to 1. Okay, so that we achieve the MSE value less than 0.002. Okay, so for part B, the circuit is exactly the same like the circuit the given circuit is consists of two parts, which is part A and part B. Okay, so for part B we only have to change the gain. Okay, so for part B, okay, the first I'm going to show you the Simulink circuit. Okay, so this is the gain. I have changed it into 0.9698. Okay, why we are using 0.9698 value? Because we gain the final result of the MSE as per required, which is less than 0.002. Okay, so I have run the circuit, and this is the waveform that we get. Okay, so you can see here. Okay, now for the value of the, since we have changed the value of the gain, just repeat the same step as part A. Okay, where we need to find the level reference data for signal 1 and then the level measurement for signal 2. Okay, so after you have gained for both of the value, we can calculate the error and also the error squared. So based on the new result of error squared, uh, we can find the value of the MSE, which is the mean square error. Okay, so we have find the value and we get the okay. So this is our report. Okay, as you can see, we have gained the value. Where you can see here the first one is 0.008, the second one is 0.0015, and the third one is 0.0011, and the fourth one is 0.0020, and the last one is 0.0008. So that's all for me. Thank you.